Welcome to the Stormsurf video surf forecast for the week starting Sunday, February 7th. Looking at significant wave heights for the North Pacific Ocean, we see two systems in play. One, a gale in the northern Gulf of Alaska, producing 34-foot seas, but for the most part aimed to the north, but earlier in its life, energy was aimed at the U.S. West Coast. And of more interest, a developing system west of the dateline, currently with only 31-foot seas, but forecast to get much stronger. First up, let's take a look at jet stream level winds. These winds up about 30,000 feet help support the formation of gales and or storms, and when those gales do form, help direct their tracks. What we're looking for is a trough. Here is a great example of a trough. That is a dip in the jet stream with wind energy, mainly in the west quadrant here, flowing south and then ridging back up to the north. That helps support a counterclockwise flow in the upper atmosphere and down at the surface, and that is the hallmark of low pressure. And of course, low pressure is what generates winds, and winds generate swell, and swell radiates towards our coast and of course makes surf. Currently, we have a good jet stream flow. 190 knot winds is pretty much on the high end here, pushing off Japan, ridging slightly over the dateline, and then falling into this trough that we talked about. This trough is currently supporting a gale that we saw up in the northern Gulf of Alaska. But also notice a big split here in the jet. That's a sign of weakness, that is lack of wind energy. When you have less wind energy, the jet tends to split like this, and you end up with high pressure in between the two split flows. That's exactly what is over California right now, making for a light offshore flow and beautiful conditions, but of course doing nothing to help alleviate the drought, nor to create snowpack in the Sierra. Anyway, let's roll this out. As you can see, winds build, there we go, up to almost, 210 knots briefly Sunday night. Continuing to feed the trough, actually starting to build a secondary trough right in this area here. 200 knot winds on Monday into Tuesday, and there's the new trough forming. That is expected to support storm formation, and a pretty healthy storm at that. And also notice yet another trough developing Wednesday night off of Japan, again supported by the same consolidated jet stream flow. Notice the split in the jet is where about 135 or so roughly come Thursday, and we'll sort of monitor that split point, but it doesn't seem to be making a whole lot of progress to the east. Anyway, the secondary trough continues over the dateline on Friday. Also notice weakness in the jet over Japan comes Saturday or so. The split point here continues moving, inching closer to, about 130 west on Saturday. The split gets more pronounced here. So the thought is we are currently in the inactive phase of the MJO, and it's not unusual for the jet stream to split in multiple places depending on how strong the inactive phase is. But what's really going on is we have, of course, El Nino. El Nino is fueling the jet stream. The inactive phase of the MJO is overlaid on top of that, just stealing some of the energy, but not totally robbing it. And still, even with the split in the jet, it's been a rather healthy jet stream flow so far since sometime in December or so, and so all of January has been quite good, and we're continuing into February. Anyway, and then notice the jet stream starts consolidating again over Japan 180 hours out, or Sunday night a week from now. So we're not too worried about the split. This is more like a momentary, just a pause in the activity. But still, the split in the jet here over the U.S. West Coast bodes not well for precipitation, at least for the next week. Let's go down to the surface and see what's going on. So here we go, surface level pressure, surface level winds, and as expected with the split over here, there's high pressure. It's actually inland here, but that is promoting a weak offshore flow or light flow along the U.S. West Coast, making for beautiful conditions. As we mentioned before, gale here in the northern Gulf of Alaska, 40 knot winds, pushing more to the northeast than at the U.S. West Coast. We'll go back and take a look at the hindcast and see how this system fared here in just a little bit. And then our newly developing storm west of the dateline with 50 knot winds as of this was 12Z on Sunday. So we'll start putting this into motion. We go into Sunday night in our storm, so that's current as of right now. Should have about 60 to 65 knot winds here approaching the dateline. That is very powerful indeed. Pressure somewhere in the low 960 millibar range. The gale that was formerly here in the Gulf is all but gone. This takes center stage. We'll just roll this out. Oops, and there we go. You can see it right there. Was at 60, 65 knots. Late Sunday night, 55 knots into Monday, moving over the date line, pushing towards, well, Hawaii's here, aimed a little bit east of Hawaii, more at the U.S. West Coast. Continuing with 50-knot winds into almost Tuesday morning, and then still a good solid fetch of 45-knot winds, aimed just like what we talked about before, into Tuesday, and then even into early Wednesday before it starts to fade out. And another system starts developing. We also saw this, a secondary trough in the jet stream. By Wednesday, 45-knot winds. Roll this out. Notice high pressure keeping a lock over the U.S. West Coast into Wednesday night. Thursday, 45-knot winds here, aimed very well at the Hawaiian Islands, but a little bit of a distance away. We'll just keep on going here. The secondary system makes it to the date line with 35-knot winds. And also notice high pressure here off Japan. We saw the jet stream starting to split there, and as expected, high pressure develops. The other interesting part is a new high pressure starts developing off California. On Friday, light wind pattern, but by Saturday, there's some indication of a stronger wind pattern, north winds along the U.S. West Coast, mainly California, and the main gale in the Gulf or dateline region starts fading, 30-knot winds, but holding still, and then high pressure continues along the U.S. West Coast into Sunday and some flavor of north winds. And then the model suggests yet some other sort of a gale trying to organize 180 hours out, but too far away to really be believable. The point being, a generally very healthy flow, maybe a little bit of weakness in the whole pattern come a week out, but we expect that to be short-lived, and we'll tell you why once we get into the long-term projections here. And here we go. Significant wave heights for the North Pacific Ocean. This was as of Friday night, 10 p.m., that's 6Z. Small gale developed here in basically the central Gulf, 30-foot seas, quickly ramped up. By midday Saturday, we had winds 50 knots. Now notice it's kind of aimed north of the Great Circle Pass. That is, the pass into Northern California are sort of like this. But still, a good amount of wind energy in here. So that's what, a 34, 36-foot seas probably pushing towards the U.S. West Coast. And then it peaked out by Saturday night and was already on the way down by Sunday morning. So that's good for a good little pulse of swell, mainly for the U.S. West Coast, Central California, Northern California. So the system was a bit to the north, probably in about the 290 to 295 degree range relative to the San Francisco Bay Area. Swell probably into Monday and Tuesday. Nothing large, but rideable just the same. And now moving to the current situation, of course, we saw the gale. The gale we just talked about fading up in the northern Gulf. New system developing just west of the date line, a little bit further north than the other systems we've seen, which have been down here around 35 and starting more on the date line and working their way into the western Gulf. This one's displaced a little bit to the west and a little bit to the north. Seas building into Sunday night. Into Monday, quite healthy. Again, 54-foot seas. This is actually a slight uptick from the previous run, the 12Z run, which was about in the 52, 53-foot range. Anyway, comes barreling across the date line into Monday night, still with 50-foot seas, or 51-foot it says here, but that's generally functionally probably about 50 feet, and then fading into Tuesday from, what is that, about 45 feet or so, and then fading while passing north of Hawaii. And you can actually see, we'll roll this back, just watch Hawaii here, and you can actually see raw seas from this system pushing into Hawaii on Wednesday. Seas in the 18-foot range. Also the swell front, if you want to call it that, working its way towards the U.S. West Coast. Still 32, almost 34-foot seas in the Gulf on early Thursday, fading out. And then swell working its way into the U.S. West Coast for Friday and Saturday. Next system, we'll roll this back and take a look, of course, also is forming off of Japan on Thursday. Not particularly impressive, 35-foot seas basically, working their way to the date line and then fading out. But still, that's good for another pulse of swell, and you can actually see that energy starting to move into the Hawaiian Islands on Sunday. So that's a week out if everything goes as planned. Oops. and then yet another system, probably not going to be impressive at all, starting Sunday night off the Kuril Islands. So basically, four systems in play. That is one for California early week, the big system, then maybe midweek for Hawaii and later week for California. Yet another system that we talked about coming off Japan, moving into Hawaii for the next weekend, and then this system finally. So a lot of activity still going on in the North Pacific thanks to El Nino. And the good news is, for the most part, high pressure and light winds over California for the bulk of that. Now we're going to do a little comparison. We're going back to Tuesday last week. This is what made swell number 8, that very large swell that hit Mavericks with absolutely exceptional conditions. This one had 51-foot seas, and see where it is, just basically north of Hawaii here. And now here is the projections for the system coming up on Monday, Tuesday. Notice it is basically at the same position farther north. What is that, about 43 north? But positioned out by the date line instead of in the western Gulf. So what this means is there's a lot more travel distance, like 2,400 nautical miles or 2,300 nautical miles to the U.S. West Coast versus 1,600 for the other system right there into the U.S. West Coast, meaning more swell decay, more space between the waves, less consistency. So one would not set their expectations too horribly high for the U.S. West Coast. Now, relative to Hawaii, of course, it's a different story because, see, this system peaked out. It was due north of Hawaii, basically only a glancing blow of energy at best, whereas this new system for coming Monday, Tuesday has much more opportunity to push energy into Hawaii. In fact, let's examine that. So here we go. Here was the situation for the last storm relative to Hawaii. You could see it kind of had 32-foot seas in the Great Circle Pass on about the 331-degree path to Hawaii, but then pretty much blew past Hawaii, and all the energy, and then that was the peak right there, was aimed much better into Northern California than Hawaii. Now here's our next system as of Sunday night with projected, about 43-foot seas on the 319-degree track, a little bit, crossing the tracks into Hawaii. But still, there you go, peaking out with, about 54-foot seas on the... about 330, 328-degree track to Hawaii. Again, still sort of aimed across them, but certainly much better position than the last system. So the expectation, again, is that Hawaii will see much more energy relative to the previous system. And, of course, Northern California also very well positioned. There's the 296-degree track right there, and the swell energy basically is between there and the 292-degree track, and even a bit south of there. And for that matter, even relative to Southern California, we'll just play this out here. What is that, about the 300-degree track into about the 295, something like that, with some energy further south. So maybe a little bit too far north to be optimal for Southern California. But again, a Hawaii and Central California swell is what it looks like. So a good bit of activity for the next week for our forecast locations. Let's start taking a look at the longer term projections. And of course, that's all dictated by El Nino. And our El Nino is very strong, but probably doesn't top 97 and probably doesn't top even 82. And we'll show you why in a moment. So we'll take our usual tour, start by looking at winds in the Kelvin wave generation area. That's that area from about 135 east to about a little past the date line, let's say about 165. So right in here and just 5 degrees north and south of the equator. And same thing here. So this from the TAO buoy array, this is actual winds measured by buoys, not modeled, not anything. It's about as real as you can get. Generally trades well in control north of the equator. South of the equator, a generally very light wind pattern, but a little bit of westerlies showing up here and there. And that's actual winds, anomalies, differences in normal for this time of year. And that's really key to monitoring what's going on and what's feeding the jet stream. Westerly anomalies still in play, even though we are in the inactive phase of the MJO, which if anything would be feeding easterly anomalies in this area. No, we have westerly anomalies. All this attributable to the El Nino base state that's in play. This feeds the jet stream. We've seen the jet stream charts. They're doing quite well, very healthy storm track, just a parade of storms. We're working on our big storm number 9 right now, forming over the dateline. That's the 9th significant class swell of the season. Maybe there's even one that we missed in there, but we're going to go with 9 for right now. And all again attributable to westerly anomalies fueled by El Nino in the Kelvin wave generation area. We can take a look back the past few days. Kelvin wave generation area is roughly this little box from about here. Just draw it right there in your mind's eye. What you see is just a little bit of westerly winds. The oranges and yellows are westerly winds. Blues are easterly anomalies. This is up at 850 millibars. So it's really 4,000 feet up in the air, but it's a pretty good proxy for what's going on at the surface. And we'll just blast through this real quick. You see not a whole lot of westerly anomalies the past 5 days. That is mainly because the inactive phase of the MJ was sort of stomping on El Nino. El Nino is still there, still creating west winds, but just nothing super out of the ordinary. And here is the Kelvin wave generation area. Again, 135 east there, datelines here. And the strictest version of it here is 3 degrees north and south of the equator, but the full area that most folks look at, or scientists, is from 5 south to 5 north here. You can see the easterly winds, and then there's the equator running right down the middle. You can see easterly winds in the 18 knot range in patches north of the equator. South of the equator, basically calm or north winds. A little bit of westerly winds, northwest winds there, a little bit there. Nothing particularly impressive, and we'll just run this out. You can just see the flow is a little bit to the west, but mainly north, and that's just basically kind of a neutral thing. We'll keep going the whole week out here. There is some little, here we go, another patch of westerly winds forecast on Friday, and that's pretty strong, you know, in the 22 knot range, but it doesn't last very long. It's sort of transient thing. We think there's some sort of tropical activity trying to organize down here, but it's outside of the Kelvin wave generation area and is expected to fall south and really not have any effect. But light winds, again, normally trades are raging both north and south of the equator over this whole area. As you can see, trades are really limited, that is easterly winds, just to maybe the northern half of this area here, and it's pretty light winds south, so that manifests itself as westerly anomalies, differences in normal for this time of year. So no winds or light winds are the same as a westerly tendency, and that is the hallmark of El Nino. And here's another way to go look back in history. This is the whole planet just going the whole way around, but the date line is right here, okay, and the Kelvin wave generation area runs from here down to about somewhere over here. This reds, oranges are westerly anomalies or westerly winds when you're in the white. That's strong. So this is a major westerly wind burst that started right after Christmas, blew very hard, created Kelvin wave number 5, which is in flight right now. We'll get into that in a minute. That westerly wind burst went through about the 15th of January, then slowly faded out. And this is when the inactive phase of the MJO pretty much took over here. And here's where we are today. Again, just a generally light westerly anomaly pattern forecast in the Kelvin wave generation area. Nothing new, too significant. And this is just the next week forecast. So certainly if that's a westerly wind burst, we're nowhere near that. Just a light westerly wind pattern for the next week. So that starts begging the question, what is going on with the MJO, the Madden Julian Oscillation, this periodic weather pattern that basically goes it circulates continually around the planet and basically lasts for, 4 weeks in any given location. So right now, the active phase, that is right here, it's over Indonesia, and what it does is the active phase has more clouds and generally westerly wind, tendency for westerly wind anomalies associated with it. The inactive phase is currently sitting almost south of Hawaii, clearer skies, less precipitation, and easterly anomalies. So this is what is deadening our westerly anomaly pattern and has been for the past 2 weeks or so. It's also responsible for the breakup of rain in California and the clear skies that are going on. So the forecast, this from the statistic model, suggests the inactive phase is to start easing east and die, while the active phase of the MJO moves from Indonesia a little bit at a time into the West Pacific over the next 2 weeks. What that would mean is once this guy works its way towards the date line 2 weeks out, westerly winds will become enhanced in the Kelvin wave generation area. That will fuel the jet stream, and then our storm track will start raging again. As if it's not already strong enough as it is, it could become even much stronger. But if you do recall, about a week out, we saw that the storm track and the jet stream sort of splits, and that week would be somewhere between these two images. So the inactive phase sort of gets its hooks into the atmosphere, and right about the time it starts to do that, the active phase comes to the rescue and starts reinvigorating El Nino. This per the statistic model. The dynamic model is actually even more stronger, suggesting the active phase is going to be stronger when it moves in 2 weeks out over the West Pacific, and the inactive phase, of course, pretty much the same, will just disappear. So the response to the jet stream, kind of unknown, but somewhere about 2 weeks out, the expectation is someone's going to dump a bunch of gas on the jet stream fire, and it's really going to pick up, and that should start fueling the storm track. Now, the question is, when that starts happening, more than likely that split that's been sitting off the U.S. West Coast in the jet stream will repair. The storm track will come raging on shore, and then California might end up where we were back a couple weeks ago, where it was nonstop, the rain and south winds and just kind of miserable surf conditions. But then that Southern California might actually open up and become more of the surf spot. And here's yet one more way to track the active phase of the MJO by these phase diagram charts, as they're called. So this tracks here where the active phase has been, like on the 10th of January, 13th of January. Now we're into February, 6th of February. Here's where the active phase is, both per the ECMF model and the GEFS, that's the GFS ensemble model. And and you've seen this maritime continent working its way into the West Pacific, and then over the Americas into the Atlantic, and over Europe, back into the Indian Ocean, and back around the planet. So we're looking down from the North Pole on the planet and tracking the MJO's progress around the globe. The further it is away from the center here, the stronger it is. So the ECMF has it being sort of medium strong, sort of like the statistic model, and moving off towards the West Pacific 2 weeks out. The GEFS model suggests it's supposed to be stronger, which is very much like what the dynamic model was looking at, and following very much a similar path. And a bunch of other models, here's our starting point, suggest varying flavors of the same thing, from stronger and moving faster to weaker and moving slower, but all generally heading towards the West Pacific, which is a good sign. So there's general agreement on the direction. The strength is a little bit ambiguous, and the speed is a little bit ambiguous. And of course, our favorite model, the CFS version 2 model, this is 850 millibar wind projections, and this chart's a little bit different. So the date line runs right down the middle here, Kelvin wave generation area, a couple of degrees either side of the date line, let's say. Big westerly wind burst back here in October. This created Kelvin wave number 3. Kelvin wave number 4, stronger still, was created in the January time frame. Kelvin wave number 5 was created in the January time frame by even a stronger westerly wind burst, but there wasn't as much warm water for it to act upon in the West Pacific. Anyway, and then here is current time. And then here's the projection for westerly winds, and we see that come about, starting the 17th or so of February. Westerly winds are expected to build, probably pretty close to westerly wind burst strength, and continue on into the Marchish, late March time frame, driven by our friend, the active phase of the MJO. So here was the active phase of the MJO that was in effect in the January time frame. We are now in the inactive phase here, these dotted lines, but for the most part, the inactive phase is already past its peak and winding down, thank goodness. Westerly winds supposed to start moving into the far western Kelvin wave generation area, perhaps later this week. Not a whole lot expected, but by the time we get to maybe the 18th or so of February, it should start having a noticeable impact. That should start fueling the jet stream, etc., etc. We've talked about that before. We were looking for any impacts from Rossby waves. They're another kind of atmospheric wave that can influence. There is a Rossby wave in effect right now, but with the inactive phase of the MJO, they're sort of canceling each other out, and we just have a muted El Nino signal right now. Low pass filter. This is generally shows you El Nino and the relative strength of El Nino. Here is the peak of it back in October, that one little dot. And as you can see, it sort of is still fading just a little bit here with the inactive phase of the MJO sort of muting it, but then supposed to return to its full strength come, the 23rd or 4th of February and continue into early April. And then after that, you normally expect to see El Nino starting to fade and not having as much of an impact, but the reality is this has been going on for almost 2 years now, so the jet stream is not instantly going to go and fall apart once El Nino here fades out. It will take 6 months to a year before it falls into some other sort of a pattern, and what that pattern is, nobody knows at this point in time. So the most we could probably look out with any reliability is into late March, and everything looks exceedingly good. So let's talk about what westerly winds do. Well, they not only feed the jet stream, but they create Kelvin waves. That is, they transport. So here we go, West Pacific here, East Pacific here. This is the equator, a couple degrees north and south of the equator, and looking down at depth, and this is from the TA buoy array. These little X's are sensors on the buoy anchor lines down in the ocean. You can measure, look at the profile of water temperature, and clearly there's warm water and a big patch of it moving to the east, making it to a point south of California on the equator. 29-degree temperatures here, the 28-degree isotherm right here, making it to 120 west. But is the actual differences than normal for this time of year in temperatures that really matters? Normally all the warm water is piled up here in the west, but because of successive westerly wind bursts and Kelvin waves, all that warm water has been transported here. This was actually gone a couple of weeks ago, but we had that big westerly wind burst in January, westerly wind burst number 5. It's taken whatever warm water was left here, pushed it to the east, and created yet another Kelvin wave that at some point fairly soon is going to start working its way towards the surface, probably somewhere west of the Galapagos. Also notice cooler than normal waters now in place in the West Pacific, and they are slowly inching their way to the east. At some point, all this warm water, a couple of months out, is going to make it to the surface, start getting tracking towards the dateline on the surface, and this cool water will take over. And normally it's cool, all the cool waters here and all the warm waters here. Clearly we're in a reverse position right now. We are actually past the peak of what would be a normal El Nino, and we still have a rather large warm water reservoir. So this is going to be a long-lasting El Nino. This guy isn't going to die anytime too soon. The question is, how quick will the cool water take over once this warm water pool dies out? How cold will it get in this area? And then will we fall into a La Nina pattern, or will it be something neutral? Nobody knows. Way too early to guess, but we do know that this El Nino is certainly holding on a good long time and isn't going anywhere too soon. Here's another view, a sort of a higher resolution view, and it goes the whole way up to the Ecuador coast and the Galapagos Islands out here. Here is our new warm pool. What is that? 5 and 6 degree anomalies covering a good area. This was all gone almost 3 weeks ago, and now we're back in goodness, and we're just looking for some of this 4 degree anomalies here at some point to start working their way to the surface, and then we'll be able to see it erupt on the surface. And when it does reach the surface, that's what helps fuel, again, helps support westerly anomalies, helps by creating warming surface temperatures, creating thunderstorms in that area. Thunderstorms transport energy high up into the atmosphere that fuels the jet stream, etc., etc. Anyway, and here is our cool pool, of course, and it's slowly working its way east as this warm reservoir bleeds off up into the surface and erupts in the surface. The expectation is cool water will start backfilling in here, and then the demise of El Nino will begin. Another way to visualize this is from satellite data. Now, these are not water temperatures. This is strip out all the wave heights. This is from the JASON-2 satellite, and JASON-2 measures the height of waves and height of the ocean compared to normal. So what we have is this big bulge of the ocean 15 centimeters above normal right in this area here. That means that there's warm water at depth, because warm water at depth, it expands, warmer water expands, and it actually pushes the ocean surface up a little bit. And if you strip out all the tides, wind-driven waves, swell, and just get to what is normal, you can clearly see a pattern of some sort of a bulge going on here. This just confirms what we've seen in the other charts. And of course, our favorite chart, the upper ocean heat anomalies. This is the upper 200 or 300 meters of the ocean surface temperatures. And real quickly, the reds, this is warmer temperatures, and you can see Kelvin waves. So you have westerly winds here that create a Kelvin wave pocket of warm water that falls to depth and travels from west to east the whole way to Ecuador. This is Ecuador over here. This is the far West Pacific here. You can see Kelvin wave number 1 in the springtime of 2015, Kelvin wave number 2 in the June time frame, Kelvin wave number 3 in August and September, very strong. And here's the scale, 2.5 degrees above normal in this area, and yet even stronger and broader Kelvin wave number 4 that occurred in the November-December time frame. And then from that big westerly wind burst in January, here's the start of Kelvin wave number 5. And surprisingly enough, there are even a couple little pixels here of 2.5 degree anomalies in this Kelvin wave. Now this Kelvin wave here, at any point in time, you go 10, 20, 30, almost 40 degrees, 2,400 nautical miles of 2.5 degree anomalies. Well, we're into what, maybe 3 or 4 degrees. So what's that? 200 nautical miles. But we're not. The expectations are very low because, as we said before, notice here's the cool pool that's building. There's just, if you have westerly winds blowing over cool water, it's not going to manufacture warm water. Basically, all this warm water is slowly being leached out of the West Pacific and pushed to the east, and this is probably the last of it. And from a El Nino standpoint, it's actually very late in the game to have another Kelvin wave, but every little bit helps. So we've talked about westerly winds, and westerly winds take warm water in this area, push it to the east in the form of a Kelvin wave, but that Kelvin wave travels under the ocean surface down about 150 meters, makes it somewhere over into this area, eventually erupts to the surface, and then gets caught by the trades, that is east winds in this area, and starts drifting off along the equator to the west. And it is this area from 120 to about 170, that's called the Nino 3.4 region. That's where they measured the strength of El Nino. And as we can see, there's good 2 to almost 3 degree anomalies in this whole area right here. This El Nino is westward displaced. Normally you'd want to see the bulk of your warm water here and erupting in this area and then being transported off to the west. But instead, all the eruption site has been between about 120 and somewhere right in this area here. So our El Nino, not to be confused with Modoki El Nino, which is all out here, but it's not a fully classic El Nino either, and that might speak to some of the issues around precipitation into California and some of the not so fully El Nino-like weather that we've been experienced. That's not to say that with this next burst of the MJO that there won't be a deluge coming into California, but the general expectation at this point is we're not going to see 200 or 250% of normal rain in California, but normal or a bit above normal, which we'll take, but the more the merrier at this point. We really need it. Anyway, let's get into the details. We'll go quickly sector by sector, and as you can see, not a whole lot, little patches of, what is that, 2¼ degree anomalies, maybe 4-degree anomalies here and there, but nothing marked in this area here between Ecuador and the Galapagos. And here's where we were a week ago. If anything, things are getting a little cooler, but not substantially. And here's the next sector. The Galapagos are here, and we're almost out to the date line. Good pool here of, was that 2¼ to almost 4-degree anomalies here. But if you compare that to a week ago, it's actually dissipated a little bit. So again, this is all from Kelvin wave number 4. It erupted out over in this area. Trades blew it off towards the date line, and it's slowly but surely fading out. Now the good news, as we saw before, Kelvin wave number 5 is building at depth somewhere over in this area, and will eventually start erupting over in here, probably about another month out or so, and then this warm pool will be rejuvenated, and this warm pool, of course, is what fuels the jet stream and the storm track. And then finally, the last sector right here, here's the date line. Still warm water making it to about 170 or 172 west. Here's where we were a week ago. Basically, not a whole lot of change, or if anything, it's getting a little bit warmer out here. Okay, and this is the cutoff for the Nino 3.4 region. So not bad at all. I mean, very respectable. In any normal year, we'd be very excited. But, you know, with the expectations of this being a super El Nino, maybe not so much, but certainly a strong El Nino indeed. And then putting it all together, again, here's just sort of a zoomed in, nice 3-degree anomalies in patches scattered here, and along here, but mostly in about the 2 to 2.5 degree range. We're waiting to see some eruption ports, probably right in this area from Kelvin wave number 5, but we're probably still 3 to 4 weeks out from that happening. A quick look at trends for the past week. Little pockets of warming here along the equator. No cooling, which is a good sign, but nothing marked either. Just sort of a pretty much maintaining the status quo. And a quick look at the trends. Nino 1.2, this is between the Galapagos and Ecuador. And as you can see, temperatures, just like what we saw in the satellite imagery, basically trending down. Still a degree above normal, but nothing super impressive. In the Nino 3 region, basically just beyond the Galapagos and extending out into the West Pacific, temperatures really not doing too bad, plus 2.4 degrees as of today. Our peak was at 3 degrees, so we're only about 0.6 of a degree off from the peak. And that's been holding very well since in the November time frame, so still quite respectable. And a very similar, if not improving, picture for the Nino 3.4 region. This is the main region for measuring El Nino, almost at 2.7 degrees as of February 2nd, 2.7 degrees above normal. Our peak was 3 or 3.05 back in the November time frame, and we've just holding up unbelievably well. A good amount of warm water in this area, certainly fueling the jet stream and the storm track, and we're seeing good evidence of that now with our series of significant class storms that have been transversing the Pacific as of late. Now, all this warm water, Kelvin waves, westerly wind bursts don't mean anything if it's not affecting the atmosphere. One way to measure the effects of the atmosphere is the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Negative numbers, like here, would suggest at least the active phase of the MJO. If it's prolonged in the 30-day and 90-day average, that suggests El Nino. Currently, our numbers are pretty neutral at 3.30, not El Nino, not La Nina, just somewhere in between. This is a tribute. You notice, see, we had negative numbers, good solid negative numbers up till about the end of January, and then everything kind of fell apart. That is the inactive phase of the MJO having its effect. But still, the 30-day running average, yes, it's not as deep as it was. It's at minus 13.46 instead of down at minus 24, whatever it was. But still, pretty respectable, and the expectations it will fall as the active phase of the MJO takes over. The 90-day running average, good for measuring El Nino. It was down somewhere around minus 15 somewhere late last year. It's up to minus 11.14 now. Not too bad at all, and it might dip a little bit more, but as you saw in some of the other charts, we're starting to reach the end of El Nino. We've got maybe a month or so, and we don't expect to see it go down to more than maybe about minus 14 or so. But if it did that in the late February, March timeframe, that would still be quite impressive. And here's the 30-day average SOI. And you can just sort of put it in historical context. You can see the dips and the bumps. When it falls, that's the active phase of the MJO. When it rises, that's the inactive phase of the MJO. Here was the big push towards El Nino starting in 2014, but it was kind of a false start of El Nino. And then when we got into 2015, you can sort of draw a line, the average line. You can see the SOI dropped very negative, minus 23 here back somewhere in the late summer into early fall. And then we went through a bit of a inactive phase. And then recently here, again, our next active phase, that was in the late January timeframe. And here we are in the inactive phase. We expect this to fall back down maybe about 2 weeks out or so. And then that'll kind of wrap it up for this El Nino. The ESPI index, another measure, does the same sort of thing. It measures precipitation differences over north of Darwin here in this area versus this area north of Tahiti. During El Nino, you'd expect to see much wetter in this area and much drier in this area. A positive number suggests El Nino. We were up to 2.33 fairly recently, but with the inactive phase of the MJO, this number is starting to fall now. But still, clearly, there is precipitation anomalies, mainly here more out south of Hawaii and less so south of California, because most of the warm pool is in this area, and it is the warm water, or warmer than normal water, that pumps more moisture into the atmosphere and helps support precipitation. So the December ONI numbers, this is sort of another way of measuring sea surface temperature anomalies and comparing it historically. The December numbers are in 2.3, but it's this whole run here, one from, let's see, what is this? This would be, we'll have to go back, December, November, October, September run, 1.8, 2.1, 2.2, 2.3, compared to 97, 2, 2.2, 2.3, 2.3. So we're not quite as warm as we were in 97, and in 82, well warmer than 82, which was 1.5, 1.9, 2.1, 2.1, and we beat all those by up to 0.2 of a degree. So per temperature wise, ocean surface temperature wise, we are somewhere between the 82 El Nino and the 97 El Nino. But the more comprehensive way to view the strength of El Nino, not just by sea surface temperatures alone, but by other effects, like taking sea surface temperatures and the Southern Oscillation Index and the MEI and a bunch of other stuff, put it into a big pile, and then holistically compare this year's El Nino to other previous strong El Ninos. The latest data, the January data, for 2016 is in. The number is 2.2. That puts us right here. Now look up here. This is what 97 was, and this is what 82, 83 was. Now the profile here is sort of like 97, one peak and sort of a second peak where 97 had that and that, sort of a double peak where 82 was just a slow, steady ramp up. But in either case, our numbers this year are not as high as anything that's been experienced in either 82 or the 97 El Ninos, which were the strongest ever. And a super El Nino, at least according to this scale, is a MEI index value of 3 standard deviations above normal or more, we do not reach that grade, but still, this puts us, this value here is the third highest on record since 1950. So, and reasonably looking at all the other data, I tend to go along with the thought that this is probably the third strongest El Nino since 1950. So to wrap things all up, we are in a very strong El Nino, probably not a super El Nino, but the strongest El Nino other than the 82 and the 97 El Ninos, which is a very good place to be. Jet stream looking extremely good. The active phase of the MJO, not in play right now, but still, jet stream looking good, even with the inactive phase in place. Westerly anomalies in play. Storm track, quite healthy. Storm number 9, significant class storm number 9, in formation as we speak. Solid surf on tap for Hawaii and the U.S. West Coast. And when I say solid, we're talking large surf, not just rideable surf. Large surf on track. Probably focused on the Hawaiian Islands for the most part, and that's a great place to be. And with the perceived promise or forecasted promise of the active phase of the MJO pulling into effect here in about 2 weeks, then it's only going to get more so that way. So enjoy it while you can. Enjoy the nice weather if you're in the California area while you can, because the expectation is rain, wind, and probably not such nice conditions will be on tap as we get about 2 to 3 weeks, probably 3 weeks out or so. So very good setup. Enjoy it. Go get some surf. Have a good time. And we'll do this again next week. Same time, same channel. Thanks for watching.